using variation of parameters method to solve the initial value problem. So first, we need to have a minus lambda I. Let's call this matrix A subtracted with lambda I. That gives you this matrix. Then you are going to find its determinant, which gives you lambda square. Set it equal to 0. Solve for lambda. You will get repeated eigenvalues, which is 0. Plug in 0 into a minus lambda I. That gives you this matrix, augmented with 0. From the first equation, I know that k1 is equal to k2. If I choose k1 1, then k2 is 1, and my vector k is 1 1, then my vector x1 is 1 1 times e to the 0, which is 1. Now, since you have repeated eigenvalues, how you are going to find your second vector? Well, use the same matrix, but instead of augmenting it with 0, now you augment it with the vector you just found, which is vector k 1 1. Okay, so from this equation, let's see. Yeah, they are identical. So use the first equation. I have p1 minus p2 equals 1. Then solve for p1. I got p2 plus 1. If I choose p2 1, then p1 is 2, and my vector p is 2 1. So because the variable for this one and this one is different, so that's why I use k1 k2 for this matrix, but I use p1 p2 for this matrix. All right, now it's time to write your homogeneous solution. It is equal to c1 times vector x1, which is this1, plus c2 times vector k, which is this1, times t e to the 0, plus vector p times e to the 0. Now simplify this one, it gives you this matrix. Okay, then the next step is to find non-homogeneous part. So similarly, like a minus lambda I, first you from homogeneous solution, you are going to put it into a matrix, which I call matrix phi of t. So basically, you exclude c1 and c2 and put the rest into this matrix. Okay, so you have 1 1, t plus 2, t plus 1. Then find the determinant of phi t, which gives me -1, and then phi is inverse, which is equal to 1 over the determinant times this matrix. For the upward diagonal line, you are going to multiply by -1. For the downward diagonal line, you switch their positions, bring this up, bring this down. Okay, multiply them together, that gives me this matrix. Then you need to find vector u of u prime of t, which is equal to inverse 5t times f of t. Okay, so I got this operation, this expression, multiply them together, it gives me this matrix. Simplify it, I got this matrix. Okay, once I got this matrix, the next step is to find the integral of u prime to get u. So integrate this one, I got this one. Now your non-homogeneous part is equal to phi of t times u of t, which is natural log of t and natural log of t. And then your general solution is equal to homogeneous part plus non-homogeneous part. Okay, normally you will stop right here, but because you are given initial value problem, so you have to solve for c1 and c2. Okay, let's take a look at the condition. So you have vector vector x sub 1 equals to -1. So plug in 1 into plug in 1 into this one for t, gives you this expression, and 2 -1 is from your condition. Now from c1 c2 I put it into a matrix. This one just ignore it and augment with this one, reduce it down to epsilon form. I got c1 equals -7, c2 equals 3. Then my final answer is equal to this one. That's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.